Record, share my screen, and come over here. So welcome back to our big data. I'm sure everybody has been missing Postgres dramatically over the past week, and your Postgres withdrawals will be cured today. We're going to, there's this topic 8 folder right here that we'll be going over today. And there's a big set of announcements for us to go over. And after we do those announcements, we'll talk about your next homework assignment. And then that'll probably take all of today. But if not, we'll do a little bit more on the quiz practice material. This is where we ended last week talking about transactions and locks. I guess the most important announcement for today is that the quiz on this material is not this week. So no quiz this week. I get a little bit of a smooth transition back to big data here. We'll finish up this material this week though, and the quiz will be next week on the transactions. At the top of our topic 8 folder here is where all these announcements are. So at this point, everything is graded in the class. The midterm grades were all very good, very happy, very proud of you all for that. Most people got full credit. There's only one way that people missed points on the quiz, or sorry, not on the quiz, on the midterm, and that was on problem 3. And if you did this thing, you got a -4 point penalty. Here I just copied and pasted a arbitrary student solution to this that has the problem here. And the problem is that this where condition right here. So again, problem 3 was trying to find all of the actors who were in children's movies but had never appeared in horror movies. And in this case, what's going on here is this category ID here is hard-coded, that instead of saying something like category ID equals 3, we would want to have where category equals children, or where category equals horror. The reason for that is because these IDs are not like semantic things at all. If we take a look at the, I think somewhere, maybe I don't have it open. Let's come over, open up, have my terminal sessions open up right here. I just want to open up the Pagilla database for a second. We can get to that from Pagilla homework, then Pagilla-data, and I'm doing a search for category right here. So this is the command right here that inserts all of the information into the categories. And these IDs right here, they're not semantic things. These are the semantic things. The IDs are just like the numbers that just need to be unique. And so instead of saying like equals 3 here, you should be checking the actual semantic thing on the children. And so in particular, like if these were in a different order like this, that shouldn't be a semantic change for anything, but that would change the meaning, the output of this query down here. And also with like this join on this category table is actually not being used anywhere right here because the film category table already has the category ID inside of it. So the whole point of joining on the category is to actually get the name of the category. Otherwise, though, people did really good on the midterm, so very happy with that. Oh, there was my link. Any questions about why this isn't good? Okay, a few more just stylistic comments about the midterm. So I consider common table expressions, abbreviated CTEs, to be a code smell. I have never seen a situation where I thought that it was a good thing to use these as a tool to solve problems, but I noticed that, I don't know, probably 80% of students use them in the midterm. 100% okay, you don't lose points for that. but I just want to explain why I think these are not a good solution to whatever you are trying to do. The first thing here is that, so the reason most people try to use them is because they're trying to make their code more readable, but I actually think they make code less readable. And the reason for that is that your common table expressions can't be tested individually, and they're not composable with other things inside of SQL. So if I scroll up here, for example, and we take a look at this common table expression right here, anything with this with clause is a common table expression. This right here is the way to think about it is as a subtable. This select statement creates a table, and we're assigning it just this name right here. And semantically, like I know what this problem is saying, so I know what children actor is supposed to be. But if I were just to stumble upon this this table like by itself, this name right here, children actor, probably wouldn't give me enough information for me to really know that this query right here is trying to find all of the actors who are in the children category. My first instinct would be that this is trying to find actors who are young, who are children. And so what I would do is I would want to be able to run SQL queries on this code right here, like select star from children actor and actually investigate the results. But you can't do that with a common table expression. But this children actor right here is not available anywhere else besides your current query in SQL. So what I think is the better way of structuring this, if you're tempted to use a common table expression, tempted to factor things out, is to use this idea of a view in SQL. This is something that we haven't talked about, but this will be coming up on your homework assignment for this week. And a view is just a select statement that you can name. And now this name is available everywhere inside of SQL. So this children actor view is something that I can run a select statement on. I can actually investigate what the results of this are, just like select star from children actor, and I can see it all. So this is usually the better way of breaking up code and making things more readable. Down here, the final code down here ends up looking exactly the same, whether you're using a common table expression or not using a common table expression. It's just the stuff above it that's different. Question?
What is the difference then between using a common table expression and creating a template? If it just remains within the scope of that statement.
Question it. So here we have a create view command in SQL. There are 3 different types of views that you can create. This is called just a view by itself or an ordinary view. There's also a temporary view or a materialized view, or the 2 other types of views. A temporary view depends slightly, the behavior depends slightly on the database that you're using. But in general, it only exists inside of your current transaction or inside of your current session. The idea of a session is what's different between databases, and in Postgres, the way to think of a session is whenever you're running one of these pSQL commands like this is an individual session, and so it only exists for one of these sessions. The question is, what exactly is the difference between a materialized view, or sorry, between a regular view and a temporary view? There's no performance differences at all. It's just that it automatically deletes the view for you when the transaction is over or when the session is over. The materialized view is something that does have a performance impact. We'll talk about that in detail later. But a materialized view actually runs this query, saves it to the hard drive, and then you don't have to rerun it anymore. So materialized view is more efficient. There's no performance differences between a create view like this and a common table expression like this. In Postgres, there's no performance difference. In other databases, the common table expression is guaranteed to run no faster than the create view, and in many cases slower. And in older versions of Postgres, less than version 10, we're currently on version 14, less than version 10, these common table expressions are what is called an optimization barrier, and the optimizer in Postgres, which we'll talk about in a couple weeks, can't look inside of common table expressions. So more old school people will be staying away from common table expressions, also because they're just used to them being slower than other things. Did that answer your question?
Yeah.
Any other questions?
I think I tried to use these on the homework, but I was running into a problem where I think like I create a view within my session, but then I modify it, and then I have to make a new session in order to run it.
Okay, yeah, so with this create view command, maybe one of the disadvantages of it is that, and the disadvantage depends on how you think about it. So create view by itself like this will create the view permanently in the database forever. If you did, and so that means when you run your test cases a second time, this view already exists, and you'll get an error saying that it can't create this view because it already exists. And it'll keep running things, so that'll be fine. But then the code inside will correspond to the old views that you had. If you, instead of create view, if it was create temporary view, then it would only be for that individual session, and you could, and so after the test cases are done running, that view would no longer exist. Or you could drop the view and recreate it every time you alter it at all. Did that answer your question? Sort of, maybe? And maybe one last naming convention. Not everybody has this particular naming convention, but I think it's very helpful in database relations in particular, that when you're naming things, go from the most general thing on the left to the most specific thing on the right. So here, actor, like in horror actor, actor is really the most general thing. We want to take all the actors and then filter them down to be only the horror actors. So I would have named this actor underscore horror. And the main reason for that is so that when you sort things alphabetically, things that are related get sorted together. Any questions about anything about the midterm? Yes. Yeah, question is why equals 3 is not good. The literal answer is because the question was not asking for you to find the things with category equals 3, but finding things where the category name is child or children. So it's not literally answering what the question was asking for. The bigger picture question is that you never want to hard code IDs into a SQL statement. If you find yourself being tempted to hard code an ID, it's like relying on the implementation details a little bit too much. In general, the IDs can change, and so you don't want to rely on the ID being a particular value. Instead, you want to find the semantic thing. The semantic thing in this case was the name of the category, so filtering on the name of the category being equal to children here. So in the join conditions, that's correct. Like in the join conditions, you want to use the IDs, but you never want to like actually write out an ID number. If you're finding yourself writing out an ID number, that's the bad thing. But on the join conditions, that's where you do want to use the IDs. Yeah, it's a subtle distinction, but important, especially to make sure that code that works in 2023 will continue working in like 20 years from now, or even just 20 days from now. Any other questions? Okay, overall grades so far in the class, pretty good. Lots of A's in the class, happy with that. From this point forward, well, let's see. So big picture idea of what we've done so far. We've talked about kind of 3 different distinct topics. We've talked about the Docker, we've talked about Twitter, and we've talked about Postgres making it correct. At this point going forward, we're going to combine all of those things together into individual, so they're all working together. And so everything now is more important, and so everything is going to be worth double. So assignments now 32 points each, quizzes 8 points each, and your final will be 64 points. Tentative schedule for things coming up. So this assignment that we'll talk about today, due next week, 3 assignments right here, all related to combining SQL and Python on Twitter data. This first one will be, well, so the big picture idea of all these things is we're going to be completing your Twitter assignment, redoing it inside of SQL instead of using MapReduce. And we'll see that this will be harder to set up, but once you do have it set up, everything will be much faster. You can get your queries in under 200 milliseconds. So I have my thing greater than sign here reversed. It should be under 200 milliseconds. And we'll see that the queries are much more flexible, that you don't have to decide in advance like what query you want to run. You can change your query however you want it to be. All 3 of these assignments, what they're doing is getting this problem set up. We'll start with doing sequential insertion, just getting the Python code working. Then we'll be able to get the Python code running in parallel to insert everything in parallel into our database. And then the last thing over here is this thing called indexes, which we'll be using to make those queries actually fast. So those will be the next 3 to 4 weeks on these assignments. And then again, I have a baby due. My wife's pregnant, baby due 18 April. At that point, I'll take 2 weeks of paternity leave. That happens to be just exactly 2 weeks before the end of the semester. So no class after this, assuming the baby comes on time. And then over the paternity leave, you'll have a few required but very fun videos to watch, and the final exam. The date on that will be relatively flexible, but the main thing about it is expect it to be much harder than the midterm. I've been told by other students in the past that the final is much harder than the midterm was. And that's because instead of just writing working SQL, you'll have to make your SQL the most efficient possible SQL. And so lots of other things that you'll have to consider there. Students who are not graduating will also then have a final project. May 12th is the last day of finals week, so that's when the final project will be due. Any questions about any administrative stuff for the rest of the semester? Okay. Then on to technical stuff. So the assignment is your next assignment posted right here, Twitter Postgres. And we'll spend most of today taking a look through this assignment and just getting familiar with what you need to do for it. First thing you'll notice is that there's 2 of these badges inside of here, 2 sets of test cases. And that's because there's going to be 2 different databases that you're working with. I'm going to switch over now to a terminal session, and we'll just take a look at the files here in the terminal session. If you want to follow along, then this is the Twitter Postgres assignment. This repo right here is the one that you'll want to clone and take a look at. So in the Twitter Postgres assignment, type ls down here. There's a lot of files inside of here. This services directory, so that's where all of our services Docker containers located. There's 2 databases, a denormalized database and a normalized database. We'll go ahead and take a look at inside of both of these 2 things. Inside each of these folders, there's just the Docker file and a schema.sql file. And the schema. All the Docker file does is load up a Postgres container with the schema.sql file. And inside of these schema files, let me make this a little bit bigger. You'll notice that these files are all going to be contained inside of a transaction. So the very first line up here, begin, the very last line down here, commit. And one of the nice things about Postgres, you can't do this in any other database, is that these data definition commands like create table, you can do those inside of transactions. And so we can guarantee that if we are able to create one of these tables, we're guaranteed to be able to create all of these tables. The denormalized database is very simple. It just has a single table inside of it, and the table has a single row, a single column that type is JSON-B. This JSON-B type will allow us to store JSON directly in the database. I'm going to switch over to our notes over here and have a few things to say about the JSON-B type. So this is under the lecture notes of topic 8 right now. So JSON stands for JSON, B stands for binary. This is the standard way inside of Postgres to store JSON data. And if you're interested in the Postgres full JSON support, this is the video to watch. This is one of those videos that you'll have to watch over the paternity leave. This the video is it's from the guy who actually implemented this in Postgres. So you're getting it from a good source, and he's I don't know, quite the character, fun to watch. The summary is that JSON support used to be the killer feature of things like MongoDB. So these are these NoSQL database systems. They became very popular in about 2010 when JSON also became very popular. And Postgres implemented this in 2014 and actually now has better support than MongoDB and all these other NoSQL systems for JSON. The Postgres team led the standardization effort for getting JSON into the ANSI SQL standard and is currently the only relational database that is standard compliant with JSON support. So MySQL, SQLite, Microsoft SQL, they have no support. Oracle has limited support. Postgres is the only one that has support comparable to something like MongoDB. And as an aside, just a cultural aside, that I'm very careful in all of these notes to distinguish between JSON in backticks and JSON not in backticks. That if it's inside of backticks, I'm referring specifically to the implementation in the Postgres system. Not in backticks refers to the more like abstract platonic ideal of what JSON is outside of any particular implementation. And this, if people are doing this correctly, putting backticks around words like JSON in the right locations, that's probably the number one indicator that I can use to tell like how competent a person is as a programmer. That if you know these, it's a very easy signal to measure, and getting these in the right spots. It's something that people who are good programmers do naturally. Nobody really explains this to them, but yeah. So it's a subtle grammar point, but I would, when you're writing this out, focus on doing it correctly because it does tell a lot about you. Okay, I'm going to go into next, actually open up Postgres and see how to use this JSON type, and then we will see how the repository uses this JSON type. I'm going to come over here back to my terminal session and resplit it like this. In the top session, I'm going to run my psql command. This is the psql command, so I press Control-R to run it. This is the same command that we've been running in the previous assignments. This command will not work because this right here is supposed to be the name of the service that you're running. And our services are now not just PG, because we have two Postgres databases, but PG denormalized is the one related to Postgres. So that's what, or the one related to JSON. So PG denormalized like that is what we're going to use to connect. Inside of Postgres, so again, we can, what I'm going to do is I'm just going to type some JSON out here, and we'll use our select statements that don't have a table to explore the JSON syntax. And in order to insert JSON into Postgres, you just type the JSON directly into a string. So something like hello colon world. This is a JSON object right here that has a key of hello and a value of world. By default, like this is going to be just a string type. In order to make it actually JSON, you typecast like this to JSON, and now this is going to be a JSON object, and we can use all of our JSON functions on it. The most important of those JSON functions is how can we get access to a particular like entry inside of here. And we might hope that we could do something like square bracket indexing like we do in Python and most programming languages. This does not work though, because again, Postgres and SQL, very old programming languages, they don't support this operator overloading. And so the square brackets only works on this array type. And so they introduced this new syntax of arrow syntax. This arrow syntax, you use an arrow. The thing on the left is going to be your JSON type, and the thing on the right is the key that you are accessing. So this right here will give me access to hello, to the world. Finds the hello key right here, and it gives me the value of world over here. This, for those of you who've used C++ before, this is supposed to be remind you of pointer dereferencing of that operator. Inside of the test cases, or inside of the SQL code, I'm going to, so down here, we're looking at the denormalized schema.sql file. And again, we have just one table right here, but then there are many views that are defined on this table. So here we have a view tweets, and this is going to give me a table of all of the tweets. It has this select statement, and the way that I know that like what information is going to be in this select statement is I have this data column. Data is the only column right here. Data is the only column, so it has all of the tweets inside of it. Each tweet is an individual row, and then we can extract the information from each of those JSON tweet objects using this sort of syntax. There's occasional like typecasts that have to be done, but otherwise this is hopefully going to be mostly straightforward. These to-do sections right here, these are not things that you have to worry about or implement. These are just notes for me that this is not the, we're ignoring all of the geo coordinates information. The actual incantation to extract that information is too complicated, so I didn't include it. And so there's a handful of views that have all of that, or give us useful information about the Twitter objects here. For this assignment, you're not going to have to write any code that extracts this information. You're not going to have to write any SQL code. You're only going to be writing Python code. But in order to make sure that your Python code is correct, you'll have to just be able to read and understand what this SQL code is doing. I'm going to talk about one more thing, and then I will pause and see if there's questions. So down here, notice that when I'm opening this file, I'm doing it all from my root project folder right here. So what that allows me to do, :tab-e SQL, I can take a look at all of the test cases down here. The test cases are divided into complex test cases and simple test cases. And so if we do tab-e SQL / we'll start with the simple test cases like this, select count star from tweets. All the simple test cases just look something like this, where the relation over here on the right-hand side is just one of these relations down here. So this tweets relation. Again, a relation is a general name for either a view or a table, anything that you can run select on. So this is a relation, this is a relation, and we're just counting how many things there are inside of each of these. The complex queries are more complex. They actually do something like what your Twitter MapReduce assignment was doing. So here, this one is calculating the number of tweets that actually use #coronavirus. And so this 6-line, 7-line SQL statement is equivalent to all of the Python code and the Bash code that you were writing for your MapReduce assignment. Again, you're not going to have to write any code for these test cases up here. Instead, you're going to have to write Python code that inserts information into the database so that these test cases pass. So the important thing is that you'll be able to read these queries, but you don't have to write them at this point. Any questions so far? Yes.
For the 2 ports, do you have to connect them?
Pause that. I just, well, I'll get to that question next. I just want, are there questions about the JSON SQL? Yes. Oh, question is meaning of 1 arrow versus 2 arrows. That's a good question. With a single arrow like this, the result type is another JSON object. With 2 arrows, the result type is a string. In general, all of these, so in order to chain these queries together, like this line right here in Python would be something like data square bracket user square bracket ID like this. This is the Python version of this SQL code right here. And in order for this thing over here, in order for this thing right here to make sense to continue indexing, this has to be a JSON object. So the single arrow like this gives you a JSON object, that gives you a JSON object. The double arrow like this returns it as a string. And so your final thing that you want is usually a string. And so it's common to have single arrows on the left, and then the very last thing be a double arrow like this.
Does it mean like you say
Exactly. So yeah, here the question is, where is this data column coming from? If we come down here, this is selecting from tweets underscore JSON B. And so the JSON tweets underscore JSON B table right here only has a single column data, which is this JSON B type. This is very common in Postgres when you're using JSON to just have a table that has a single column inside of it, which is the JSON information right here. Question is difference between JSON and JSON B. The answer is, from a user's perspective, none. JSON B is just a little bit more efficient. All the interface for using it, though, is exactly the same. So whether we had JSON or JSON B like this, there'd be no difference. In older versions of Postgres before, so like say 2010, there's only this older format of JSON, and this JSON B is a newer-ish 2014 edition that makes things a lot more efficient. Technically, the difference is that you'll be able to create indexes, which we haven't talked about yet, on the JSON B type, and you can't create indexes on the JSON type. Good questions. Any other questions? Okay. So back to Sophia's questions about the ports. Because we have 2 different Postgres instances running here, I'll open up my docker compose.yaml file. We have 2 different Postgres instances running here. Under this ports section of the docker compose.yaml file, we need to specify 2 different ports that those instances are listening at. And in this case, you can't just use your user ID because there's 2 different things that you have to specify. And so here I selected 10,000 and 20,000, but you'll just have to make sure that you select 2 numbers here that are different than the than anybody else's numbers in order for your program to bring itself up. If you do, if you're able to bring it up, then you know that everything worked correctly. And but if you get errors bringing it up, it's probably because you need to specify these port numbers right here. Did that answer your question?
Yeah, I was just also curious, where is the first like left thing you said?
This?
Does that matter? Choose it.
So this is the port that's exposed on the Lambda server. So this is the thing that you have to change. The right-hand side over here, this is the port inside of the service, inside of the container, and 5432 is just the port for Postgres.
So like, why exactly does this one, like, why is this one exposed to the server? For Pagilla, it doesn't matter.
Good question. The question is, for Pagilla, you didn't have to change the ports at all. And on this one, you do have to change the ports. The answer is, I just wanted to make you have an error when you first ran the Docker Compose file and have to fix it. Any other questions so far? Okay. Yes.
So how can I? Oh,
Yeah, so in order to get into pSQL, it's the same Docker Compose exec command, but then in this case, because there's two different Postgres terminals or two different Postgres services, you'll have to be very careful about whether you're using the PG denormalized or the PG normalized service here. Okay, we're going to talk next about exactly what the test cases look like and then how to, what you actually have to do to complete the test cases. So over on the assignment, there's these two badges right here. Each one of these badges corresponds to a file in the .github/workflows folder. So there's this denormalized and normalized files. I'm gonna go ahead and open those up in Vim, workflow/star-p. These files are the same. There we go. So I have, just reopen that up. I'm just opening up my workflows, all the files in the workflows folder. Each one of these workflows corresponds to one of those buttons. These files are exactly the same, except that you can see that the very last line is different. One of them is run on the denormalized database and one of them is run on the normalized database. In both of these things, it's first getting any extra data that we need, building the Docker container, and then the actual important command here is that it runs the load tweets.sh program. And your load tweets.sh, this is what you're going to have to implement so that when it runs the test cases down here, these test cases are going to pass. And these two, the denormalized and normalized, totally independent of each other, that each test case is only running on one of these databases. So let's take a look at that load tweets file. So vim load tweets.sh. And there's two components of this file. First, it's going to load the normalized database right here, and then load a denormalized database down below. In order to load the normalized database, in general, anytime you're loading a normalized database, you're going to have to write some Python code that will do that for you. And the denormalized database, anytime you're loading in that, you're going to use what's called the SQL copy command to get things loaded. We'll go over the SQL copy command here for the denormalized database. That will be everything that we need to know about the denormalized and JSONB stuff. And then we'll start talking about the normalized database and comparing them. The copy command, if we keep going down a little bit, go down a little bit further, here's the copy command. When you're inserting things into SQL, you have two options: the insert command we've seen before, or this copy command. In general, the copy command is significantly faster than insert. And so if you can use copy, you want to use copy. Copy is easiest for using CSV, but it supports a number of other data types. And in order to use it for JSON, this is the incantation that you'll need. It's pretty long and nasty right here. Your documentation for understanding what all is going on here is this link right here. And I'm going to make you all read this link to figure out what exactly is going on here. But in order to pass all of the test cases for the for the denormalized, for the JSON version of things, all you have to do is take this command, edit it properly, and paste it into this line right here, line 17 of your load.sh file. And then it will correctly import everything, and you're done with the denormalized database. So any questions about what to do for that? Okay. So the denormalized stuff is going to be relatively easy for this assignment, and the harder part will be dealing with the normalized database. For the normalized database, it's going to be calling this load tweets.py file. And so we'll take a look at what's going on in this file, what you have to do for it, and also the SQL code for the normalized database. Up here on the top, I'm going to do :QA. Let's get out of that. Let's get out of this one down here as well. Let's reset both of these things. And then instead of looking at the denormalized schema right here, I'm going to change this to look at the normalized schema.sql file, and we'll open that up. Here again, everything inside of a transaction. Down here, though, there's going to be a lot of different tables. So I'm going to do a / for create table. And you can see that there's going to be many different tables with different types of information inside this database. If you come over to the assignment repository, scroll down a little bit to this bullet point 2 right here. Here is our entity relationship diagram for this database. I just drew it by hand. Again, each one of these boxes is one of these tables, and all of these arrows represent foreign key constraints. So this tweets table is sort of the most important one, but every tweet is going to have a user. Each user might have multiple tweets. If there is a mention in a tweet, an @ then there's this tweet mentions table, which stores that. A lot of many-to-many relationships going on here. Many URLs can be inside of a tweet, and many tweets can represent the same URL. There's these 2 linking tables for both of those. And then each tweet can have many tags associated with it. So there's this tags table over here as well. The interface for this database, I've structured it so that I'm going to tab E. Services. I'm opening up the PG denormalized schema right now. The intended meaning of each of these tables corresponds to the view that's expressed down here. So here we have this view of the tweets, or this tweets view of the JSON-V information up here. This tweets view is intended to be exactly what the tweets table stores inside of it. Here's the tweets table. So the contents of the tweets table right here should be exactly the same as what this tweets view is on the JSON object. So here in this view, we're using SQL to extract the information for the for this tweets relation. Here in the normalized version, we're going to be hard coding all of this information in, and you'll be using Python to do that, to do the processing. Again, that Python is all happening in the load tweets.py file. And here we go. So we're in the load tweets.py file right here. Anytime you're looking at one of these Python files, the first thing I always do is go to the bottom of the file. So Shift-G and Vim, and then find the underscore main line, this line right here. This is going to be the line that or this is the location where our program starts processing. Processes a few command line arguments, This is a little bit of boilerplate up here, creating the database connection, and then looping over whatever our input file is down here. The input file to this program is going to be just those same zip files that you were working with in the previous Twitter assignment. So this set of for loops and things should look very similar to you from what the previous assignment was doing. It'll loop over each one of those lines one at a time and extract the JSON information right here. And then it calls this insert tweet function to actually insert the tweet into the database right here. This insert tweet function is the one that you have to implement. It's the only thing that you have to make code modifications to. It has this fix me right here, just saying that you have to implement it. And basically, there's a bunch of these SQL variables down here that is currently totally empty. And what you'll have to do is actually provide the appropriate SQL statement right here. Could be an insert statement or an update statement that you'll have to write. Most of them will be insert statements. And I already provide you all the information. The code up here extracts the information from the table or from the JSON object that you need. And you just have to insert it into the database with an appropriate insert command right here. There's lots of these different SQL statements right here. One for each of the different tables that you have to create. And so you have to get all of those implemented. If you, as an example of what these implementations look like, this get ID URLs or get id URLs function has a full working example. That inside of your SQL, you'll have something that looks like this, insert into URLs. You'll have your list of columns that you're inserting, then values. Anytime in SQL you are inserting things into the database, you'll always use this syntax right here that says colon, then the name of the value that you want to insert. And then down here, this connection.execute, you put a dictionary right here, which passes in all the actual values into the SQL string up here. So for your code, again, you'll have to add the appropriate SQL command inside of here and add the appropriate call to this execute function, which actually executes the SQL command and passes the appropriate data to the database. I realize that's a little bit high level still, but any questions about that? Okay. Let's come back over to the notes here, and I have some more high level notes and then some more hints about what to do when things go wrong, which will probably happen. So first high level thing is that why would you choose maybe the denormalized versus the normalized version of the database? One of the purposes of this assignment is to get you familiar with the advantages and disadvantages of both of them. You'll see that the denormalized one is much easier to insert things into, but the main problem with it is that the database will not ensure that your data is correct in any way. It's up to your Python code to ensure that the data is actually correct. And I don't know, for beginning programmers, that seems like a good trade-off because you're you're less familiar with SQL and you have maybe more confidence in your ability with Python than you probably should. But really, like for an experienced programmer, having Python code checking that your data is correct is something that should like legitimately terrify you. If you were a CTO of a company, this would be the sort of thing that's keeping you up at night. The reason for that is your database is the ground truth of your business logic. And if somehow you have an error in your Python code, so you end up with wrong data in your database, there's nothing that you can do to fix that. So you really want to, if your data is important, then have appropriate constraints to ensure that your database will never get into a bad state. Examples of those appropriate constraints are these foreign key constraints between each of these tables right here, and like the similar unique constraints that we were talking about before spring break. Why would you ever want to do things in denormalized form then? If the data is given to you in denormalized form, so like the Twitter data is given to you in denormalized form, then you can rely on the original data source of doing those integrity checks. But if you're creating the data yourself, then I would always store it in a normalized form. Any questions so far? Okay, so the section on connecting to Postgres from Python here. This is all just background information. This transaction part right here, this is going to be important. This connects to the stuff that we've been talking about inside of the quiz, that when you're working inside of Python with SQL, you never actually explicitly run the begin command or the end command. Instead, you'd use this syntax right here with connection.begin as trans, or as whatever you want your transaction to be called. And this initiates the transaction for you. If you come back to our insert tweet command right here, and I'll just do a search for the with, all of your code will be inside of a transaction, because on line 106 right here, it's all inside of this transaction block. What that means is that all of your foreign key constraints and unique constraints will have to be satisfied at the level of the transaction, and exactly what that means we'll cover when we get to the last half of the quiz. But it's important that everything in your function will be inside of this transaction right here. Again, writing your queries, all the code that you write will just look something like this, putting the query inside of here and then running an execute call on it. If you're ever having to loop over the results, an important thing is that, so this here, when we have our connection.execute, this RES, short for results, very common abbreviation to use as whatever this execute returns for you. In Python, this is what's called an iterator. And a common beginning mistake is to convert that iterator into a list using something like this. But this is very bad in practice. It has linear memory consumption. And so once we get to scaling up our database here, it will be extremely slow and your code will start breaking. So if you see yourself tempted to do something like this, you're definitely going down the wrong path. Instead, what you'll always want to do is just loop over the results of your select statement doing something like this, and this will have constant time access to the rows and constant memory usage. Once you have extracted an individual row like this, the way you get access to the ith column, you can use both numbers and strings column names here. It's just like this ordinary square bracket syntax in Python. As an aside, those of you who did not do data structures in Python, you probably haven't seen this iter, next, and get item magic methods in Python. All of this stuff up above is implemented using those things, and you don't need them for this assignment, but I would definitely recommend trying to understand them at this point, so that they're definitely things that, say, at a technical interview, you would have to know about related to Python. So if you haven't seen these before, then this is a good tutorial right here to just get yourself familiar with them. Any questions so far? Okay. This properly escaping your inputs, what I mean by that is if we come over to our code over here in the SQL, there's many ways of generating, so like this user IDs right here. There's many ways of generating SQL commands that we could use. One thing we could do is insert into users, user ID, URLs, values, user ID URLs, something like this, using Python to insert the string. but you don't want to do this. You never want to use Python tools to construct your strings for you. Never use Python to construct the strings. If you do that, you will not be able to pass the test cases on this assignment, and it'll be very confusing about why that's the case. The reason this is bad is because it allows other people to insert SQL commands into your code that, here's a, let's see, famous XKCD comic right here that person's name contained SQL code inside of it and resulted in, so here this, did you really name your son Robert drop table students? And then this single quotation mark right here would end the SQL command and create a new SQL command of dropping the table. You don't want that to happen, and using the this style passing in dictionaries with the information will avoid that from happening, prevent that from happening. In the 90s and early 2000s, this was a really easy and common way to take over most web pages. There's a lot of companies whose names are just these SQL injection and vulnerabilities. Nowadays, though, libraries like SQL Alchemy have good tools for avoiding these problems, avoiding these injection attacks, and so it's not common to have these happen anymore. The fast explanation of that, but any questions? Yeah.
How does moving it into a dictionary, is it by what the algorithm does? Like, how does putting it in a dictionary mean that you can't just do the same thing?
Yeah, question is, won't it still have the same value right here? The answer is that SQL Alchemy will escape those things for you. So if there's like quotation marks, if our user id URLs was equal to something like that Robert drop table users like this, then SQL Alchemy will find these quotation marks and put the appropriate backslashes and things in front of it so that it's not interpreted as a SQL command.
Oh, so then it would just be the string would be Robert drop table users.
And so this would be the actual string, yeah. That would be the actual value in the database. Good question. Any other questions? Some more fun Python that or SQL that you'll need when you're doing your insert statements. Occasionally, you'll be inserting things that will violate unique constraints. The main way that will come up is on the users table. So the users table right here has our primary key right here on id users. And again, primary key means that is a unique and not null, that there's no difference between primary key and the unique not null. They're synonyms for each other. So we have a unique constraint right here. And so every time we're adding a tweet, we also have to add the user into the users table right here. And if that user already exists, you'll violate this unique constraint right here. The easiest way to deal with that is to add this on conflict do nothing, and then it just won't do anything. If you don't add this line right here, then you will get a error message thrown in Python saying that you're violating the unique constraint, and you'll have to have a try except block to try except block to catch that. Another super quick aside here, I often say throwing an error, but in Python, it's more technically correct to say raising exceptions. And So if you hear people talking about throwing errors, you know they're not native Python programmers. My first programming language was C and C++, where they talk about raising exceptions instead of throwing errors. So you can tell more information about the history of or the background of somebody with those subtle things. I try to say raising exceptions when I'm talking with Python, but I very rarely do that. Last thing on the insert statement here. It's also common to want to return the things that you inserted. So returning column list is what you can do. There's an example of that already in the load tweets right here on the this get id URLs function, returning id URLs. Having this line right here makes this equivalent to an insert plus a select statement, and and you don't have to have an explicit transaction combining those things together. So if you're ever trying to get the result of your insert statement, then this returning id URLs, returning whatever the thing is that you're trying to get, is the tool to use for that. There's a couple of places where you'll have to do that or use these tricks. Down here, yeah, so here I have some hints for you on like when the on conflict do nothing and the other the returning URLs is going to be useful. Last thing to note about the assignments. So the insert function or the insert code is going to work and be correct, but it's not particularly efficient. It's the most efficient way is that as you're inserting, do it in batches, like say 100 rows at a time. That makes the code more complicated though, so we're not going to do that in this code. You should expect your implementation to be between 10 to 100 times slower than the denormalized code. And the most efficient like implementation of this would be about 2 to 4 times slower than the denormalized code. But no matter what, you can't be faster than the denormalized code. The normalized is guaranteed to be slower than denormalized. Any questions? Okay, maybe one last note about this. Is that a question? I'm going to come back over to the terminal over here, QA, bang, ls. This test data.zip, this is the actual data that you'll be loading that the test cases are built around. So again, I'm already providing you all of the SQL code, all of the expected output here, and you're not having to write the SQL code, you're just having to write the code that's inserting information from this test data.zip into the database. Take a look at testdata.zip. It's the same format as your the previous files that you're working with. There's only about 10,000 lines in the file though, so it's small enough that we can include it in our Git repository and upload it to GitHub, have GitHub Actions run against it. And in general, when generating test cases for like large data sets like this, it's very common to create a very small test case, pass that around with your GitHub repositories for continuous integration purposes. But then when you actually sort of use this in production, you use it on the full data set. And so at this point, again, we're just focusing on correctness, getting this stuff loaded in. Your next assignment, it's going to use the same code that you write for these two portions here. You'll just be extending that to use the actual Twitter data set with the large gigabyte files rather than this small toy data set right here. Any questions? Everybody's exhausted from spring break?
I think that's just for planning purposes.
Sure.
Do we have a lab this Friday?
There will be no sort of assignment or lecture-ish material during the lab session this Friday, but it'll be like an office hours session. I'll be available for questions. Okay, we only have about 5 minutes left of class. That's not enough time to make meaningful progress on this notes thing over here. So we'll call it quits for today, and then Wednesday, again, no quiz, but we will finish up this talking about the notes stuff for the next quiz. If anybody has questions about anything else, happy to stay after and get those questions answered. Have office hours now. But otherwise, that's it for today.